Hello, class. Mrs. Chisholm here. We are getting into Module 2 today in this video. So I am going to share my screen so we can get right into it. Okay, so here I have chosen some problems from 2.1 that I think would be really good to look at. Not so much because they're so hard, but because I can show you a quicker way to do them. Now, you do have some calculator tutorial videos that are embedded in Pearson in your assignments, and they don't necessarily count towards your grade, but they are so important for you to watch because they will help you to be able to, utilize your calculator and shorten a lot of your work. So module 2 kind of kicks us off where we are having to do more calculations. And you got the technology, so utilize it, okay? Because some of these formulas in statistics can get rather long. This is different from algebra where you're just solving for x or, finding the value of x or evaluating something. Here you've got some monster formulas sometimes, all right? So I'm going to show you I'm going to show you how to do it on the calculator as often as I can. All right, so I have an 84. It's the color edition. Yours doesn't have to be. If you have an 83, it works too, okay? So whatever you have, as long as it's a TI instrument, your keystrokes, what we do on the calculator should match mine, okay? Where we have a little slight difference from the 83 and 84, I'll show you, but for the most part, they're the same. All right, so here is this first problem that I'm looking at here is number 5 from 2.1. It says the numbers of regular season wins for 10 football teams in a given season are given below. Determine the range, mean, variance, and standard deviation of the population data set. So in 2.1, we're looking at measures of central tendency, which is mean, median, and mode. And then we're looking at measures of spread or dispersion. Sometimes texts call it measures of dispersion. Some texts call it measures of spread. Okay. So measures of dispersion represent range or are represented by range, variance, and standard deviation. The most common one that we'll use after this section will be the deviation. Pretty much once you're past this module, you won't talk about range and variance too much, but deviation we'll discuss again later, as well as the mean. You may not see median or mode talked about a whole lot after this module either, but the mean is super important and the standard deviation. Okay, so let's see here. Of course, you should have looked at the lecture videos and taken the notes and seen the formulas for finding these values already, okay? So I won't go into a lot of detail about the formula necessarily. I'm going to show you how to shorten the work, okay? So let's first determine whether we have a population. Actually, they tell us. Sometimes in the problem, it won't tell you. Sometimes you have to determine it, but we are actually dealing with a population here. So the mean, when you're dealing with a population, is called mean mu, okay? The range is just the range. Then you got the variance, which is called sigma squared. And then you got the standard deviation, which is the square root of the variance, which is just sigma. So the mean is found when you take the sum of all the x values and divide it by the number of values. So when I say x, I mean data entries. So it's the sum of all the data entries divided by the number of data entries that you have. So to get the mean, it wouldn't be hard to do this by hand. We would just add up 2, 8, 15, 3, 15, 7, 15, 6, 4, 7. Add all those up, get that sum, and then we would divide that by 10 because we're told that we've got 10 different football teams that here are shown is representing 10. Or you could just count that we got 10, okay? Now, the variance formula, that is, let me see, that is the sum of each data entry minus the mean squared all divided by the total number of data entries. That's the formula for variance. So if you watch the lecture video, it showed you how to go about getting the variance using the formula, okay? So you have to use the mean first. You have to calculate the mean first in order to use the variance formula. And then the standard deviation is the square root of the variance. So it's the square root of the sum of all x minus mean mu squared over n. Now, the formula isn't horrible, but it would require that you create a table. You'd have to find all of these differences first between each x and the mean. You have to square all those differences. Then you have to add all of those square differences up. And then finally, you divide by 10. So it just would take a little longer. And then after you have this answer, the variance answer, then you would take the square root of that to get the deviation. Well, what I'm going to do instead is use the calculator. Instead of formulas, use calculator. Okay, so what we're going to do is we're going to put our data values into a list. And I'm going to use list 1 because it's just the first list. Okay. Let me show you. I'm going to cover up the formulas because I'm not using them anyway. I want you to be able to see my keypad. All right, so I got my calculator turned on. Well, I do now. It's a little glare here. That's a little better. All right, so I got my calculator turned on. I want you to get comfortable with this calculator, okay? If you press the wrong button, the wrong key, do not fret, okay? You cannot tear this calculator up. If you press the wrong key, all you have to do to clear it is literally press clear. Or if you're on a screen that you shouldn't be on and you want to go back to the home screen, which is where I'm at right now, then you would press second mode and that would take you to quit and it would take you back to the home screen. So this calculator, because it does so much, it has key functions here, the main key functions, and then it's got the second function of these keys. So that's what you see in blue here, okay? So what we're going to do is look for the list. Let me show you where the list is. If you press the stat key, so to pull up the list, we're going to press the stat key, and then we're going to press edit, because automatically list 1 is highlighted, so you just have to select it by pressing edit. Well, or enter, I should say. To edit it, you're going to press enter. Okay, so let's press stat. Okay, edit is already highlighted. We're going to press enter, and it takes us to our list. Okay. All right, we're going to use list 1. So we're going to put these values in list 1. 2. So after I press 2, I press enter, and it takes me down to the next number in the list. 8, or the next space for the next number. 15, 3, 15, 7, 15, 6, 4, 7. So I've got 10 data values. I've got all 10 entered in because the calculator's technically waiting on value number 11 if I had it. So I do know that I have all 10 put in. Always double check yourself, look at your values, make sure you put them in right, okay? After that, then you're ready to analyze. So to analyze data values or data set, you're going to press stat again. So I'm pressing stat right here under the delete key. You see stat. And now because I'm ready to analyze, I need to go over to calculate. I need to arrow over to calculate. So I'm arrowing over. Here's my little arrow leap pad. So I'm using the right arrow key to go over to calculate. Okay. And I'm going to be using number 1. It's already highlighted, so all I have to do is select it by pressing enter. So I'm using one variable stats because I only have a single list of data values. I don't have, in other words, I don't have an ordered pair. You know, ordered pairs are X and Y. So I'm not on that data set, that kind of data set right now. I just have a single set of data entries. So that's one variable stats. So I'm using one variable stats. And again, it's already highlighted because it's the first one. So I'm just going to press enter to select it. Okay. Now, in list 1, that's where I put my data. By default, my calculator already has it there. Okay. If it did not, then I would actually type it in there. I would actually press, you see that in blue, you see L1 right there in blue. I would actually press the second key and then 1 for L1. If I had my list in L2, I would press the second key and then I would press 2. Okay, so make sure you put the right list there. Ours is L1, so second key 1. Now, if you've got an 83 calculator, if you got the old operating system, yours is going to look a little different. Okay, I'm going to show you how you would see it on your screen. Okay, if you've got an 83. If you've got an 83, yours won't show up like this. Yours will literally be imposed on your home screen, such as this, and you'll have like a little parentheses there. And all you'll do is tell the calculator list 1. That's it. So 1 variable stats, list 1. And in fact, if you don't have anything in any of the other lists, you don't even have to tell it. It'll automatically use list 1. But if you've got any other values in any other list, you want to make sure you tell it list 1. So this is what it looks like if you've got a TI-83. They would actually have this imposed on your home screen. Instead of this screen right here, what you see, you would see 1 variable stats and you would see like a little open parentheses. And you would press second 1 for L1, and then you can close it off or not. It's no big deal. And then you'll press enter. Okay. So what I've got on my screen, they've got some extra stuff going on in the 84. You know, when technology gets more advanced, it sometimes gets a little bit more convoluted, complicated. So they did some extra stuff here. They've got a column here for frequency list, and we might use that later on. We will. But right now I don't need it. It's empty because I only have one list. I don't have a single list, a single data set. So I just need to go down here to calculate, okay? And I press enter. Now, X bar is the mean mu, okay? By default, your calculator calls the mean X bar. The reason for this is because the calculator assumes that you never have access to an entire population, okay? In a perfect world, we would be able to calculate values using every element in the population. But our world is not perfect, and usually you don't have access to an entire population. Okay, so this problem is just used for demonstration purposes. Really, there's no way you have a population of only 10. Okay, but this one, it's okay. So even though it's called X bar, that is your mean mu. That is your mean. So the population mean, oh, and I need to answer that first question. I hadn't answered the range yet. Let me go back to that. The range is actually not calculated. The range, you can't find that in the calculator. The range is simply the spread of the difference between the biggest data entry and the smallest. That's it. So to get the range, we would simply say the biggest value is 15, the smallest is 2. So to get the range, we would just say 15 minus 2. So we have a range of 13. Okay. You're going to have to calculate the range by hand. Okay. That one's not done in the calculator. Everything else we get from the calculator. All right. So now back to the population mean. That is your X bar value. That is 8.2. So let me say called X bar in calculator. But they are interchangeable because the formula is the same. The way you calculate the mean is the same whether you have a population or a sample. Okay? All right. And it does say round to the nearest 10th, and lo and behold, that's what our decimal is anyway. It's a finite decimal to the 10th. Okay? Now, these next two values, let me explain something to you. Look at your little symbols here that I wrote down for mean, variance, and deviation. We got the mean, remember that's X bar from our calculator. The variance is called sigma squared, and the standard deviation is called sigma, okay? Now, we're using the technology, so we're not using the formulas. If you were using the formula, you would have to get the variance first and then get that answer and then take the square root of it to get the deviation, okay? If you were using the formula. We are using the calculator. So take a look at the calculator. Now it gives you some extra values here that we're not using, that aren't important to us. But I want you to notice that it gives you sigma, and it does put a little subscript x on it, sigma sub x. That just means our data values are called x values, okay? But it's sigma. So it does give you sigma. Turn that back on, it's going dark. It does give you sigma, but it does not give you sigma squared, okay? So in order to get the variance, we're going to take this sigma value, and guess what we're going to do to it? We're going to square it. So if standard deviation is sigma, which we have, and we want the variance, which is sigma squared, we're going to take the standard deviation and square it. So from calculator, to get variance, take the standard deviation value and square it. Okay? So sigma sub x is your standard deviation. I'm going to put st dot dev for short. And I'm going to put that value, I'm going to write it down. I'm going to use every decimal place. Okay? Now, let me say something also while I'm thinking about it. The reason it's so important that you denote whether you have a population or sample is because the calculator will give you the standard deviation when your data set is a sample. Oh man, no. Let me go back. Calculate. Okay, there are my values again. So notice here you've got S and you've got sigma. Okay, that little O there, that's our sigma. S and sigma both represent standard deviation, okay? S is just the sample standard deviation, whereas sigma is the population standard deviation. That's why it's so important that we know which one we're dealing with. If this had been a sample, then I would have had S here, and I would have had S squared here. But because this is a population, I'm using sigma. So I take my sigma value, which is 4.79165942, and I'm a stickler for accuracy. So I take every decimal place that I see from that calculator, I take that and I square that to get the variance. Okay, so I'm going to say sigma squared is 4.79165942 squared. And I wrote it down because when I get ready to type this on my calculator, this is going to vanish. So that's why I wrote it down. So 4, as you can see, 4.79165942 squared is 22.96. And I figured it would give me the exact number of decimal places that I was asked to give it to if I was really accurate. Actually, they want us to go to only the tenths. So it's still really accurate though. So that's going to actually round that 9 up, which will have to make that 2 round up. So this is going to actually be 23.0. Right here, the variance is 23.0. Okay, we had to round that up. That's the variance. Now we are going to write what the standard deviation is, rounded to the tenths. So this number right here, you're just going to round it. That is the deviation. We just need to round it. So to the tenths is 1 decimal place, so that would be 4.8. Okay, and you're done with that. That is the problem. Okay, so again, I just wanted to show you on the calculator how to work that. Okay, and I believe I've got another one similar to that. So this one was dealing with the population. So definitely watch the calculator tutorial videos. They do help you, okay? So again, it shortens a lot of your work having to do those formulas. You don't have to do it. You do not have to use the formulas. Wherever you can use your technology, you want to use it, okay? All right, let's look at the next one here. So yeah, we definitely want to do this one as well. Even though it's asking for the same values, this is a sample this time, okay? So here it says the ages in years of a random sample of shoppers at a gaming store are shown. Determine the range, mean, variance, and standard deviation. So mean, because we're dealing with the sample, is called X bar. Variance, because we're dealing with the sample, is called S. And standard deviation, again, because we're dealing with the sample, is called S. So variance is S squared, standard deviation is S when you're dealing with a sample. Okay, remember when it was a population, it was sigma squared and sigma. But here, because we have a sample, it's S squared and S. But I'm still going to use the calculator. So the range I have to get by hand. So the range, let's go ahead and see what the biggest number is and the smallest number is. So our biggest number looks like it's 23. Our smallest number, 12, I think. So 23 minus 12, what is that, 11? All right, so we have a range of 11. Got that. Okay. Now let's get everything else from the calculator. So from this point, I put my values into a list, and I'm going to use list 1 again. Okay, putting list 1. All right, so how did I pull up my list again? I went to stat, which is right under the delete key. Okay. And let me scoot that down a little bit or get the glare off. There we go. So I went to stat, and edit is the first thing. And I actually need to edit my data values in. So that's what I want to do. So to select edit, I press enter. Now, this is what I want you to be careful of. We're going to clear this list out. Do not delete the list, okay? Do not delete the list. You want to clear it. So I always, unfortunately, I always have students who will press the delete key, and that's not what you want to do. You want to clear it. So to clear a list, you're going to go up to the name of the list. So you're going to arrow up so that your cursor is on L1. So you're selecting the whole list basically. And you're going to press clear, enter. Do not press delete, because if you press delete, that whole list is gone. And we would have to reset your calculator in order to get it back. And the L1 is used all the time. Your calculator is automatically kind of programmed sometimes to use L1. So you would have to reset it in order to get L1 back. So do not delete it, okay? So we cleared the list out. Now we're going to put the data values in. So 12, 19, 23, 14, 14, 17, 21, 17, 15, 16. Okay, and I should have 10 entries in because look, it's waiting on number 11, so I definitely have all 10. Just double check, make sure you didn't mess up or enter in anything that you shouldn't have, and everything looks good. Okay, after you've edited the values in, you're ready to calculate now. So you press stat again, just like we did on the previous problem, and I arrow over to calc now. Okay, so edit data values by pressing stat and then edit, which is just pressing enter. Okay, to analyze data values, you're going to press stat and you're going to go over to calc, and you're going to use one variable stats. Again, we have a single data value set, single data values. We don't have ordered pairs or anything. So we're using one variable stats. So I'm going to select that by pressing enter. And by default, L1 is automatically there for my calculator. Okay, and I just have to go down to calculate or just keep pressing enter, enter until it takes me to calculate. You don't have a frequency list, that should be empty. Just press enter. So the mean is X bar, that is 16.8. And I don't have to round it because it was a finite decimal to the 10th place, and the problem wants me to round to the 10th place. All right. Now, the calculator gives you S, but it does not give you S squared. Variance is S squared. This is X bar, and standard deviation is just S. So to get the variance, we're going to take S from the calculator, which is S sub X. We're going to take S and we're going to write it down because we're going to square it. I'm going to use every decimal place I see because I like accuracy. And also the computer does too. It kind of can sometimes be a stickler for your rounding. So you could run into some issues with that. If you ever have an issue with rounding, let me know, okay? Because if you round incorrectly, it will count the whole thing wrong, okay? So let me know if you ever run into that, especially on a test, more so the test, all right? Like if you entered in 11.4 and the answer is 11.3, I'll give that back to you if it was on a test. Now, if it was a homework, you know, yeah, do it again or, you know, take that little loss. But on a test, I know you want all your points, okay? So just keep that in mind. You're rounding, you know, the calculator doesn't necessarily give you partial credit. So let me know. All right, so now we're going to square that to get the variance. 3.39280284 squared. So I took every decimal place, 3.39280284, and I'm going to square, and I get 11.51111. So I'm just going to say 11.51. And it wants me to round to the tenths, so just 11.5. Okay? And the standard deviation, well, that is just this value. 3.39 is this value before we squared it. We're going to round it to the tenths. So that would just be 3.4. And we're done. Okay, so technology is your best friend, I promise. Some of these problems, their formulas can be nasty, okay? So again, 2.1 starts as looking at measures of central tendency, mean, median, and mode. And then it starts as talking about measures of spread, standard deviation, variance, range. And then at the very end of it, we do talk about, not necessarily the very end, also in this section, we do talk about quartile values, the 5-number summary, okay? So basically, when you have a data set, you may want to determine how you position the data values. So you've got measures of central tendency, you've got measures of spread, and you also have something called measures of position. So where your data values fall in reference to the first quarter, the median, and the second quarter or the third quarter quartile, that's what we talk about with the 5-number summary. So I am going to attempt to do this problem in the hopes that you've already looked at the lecture video and that you have an understanding of what Q1, Q2, and Q3 are, okay? To do this by hand, you would need to order the data values, and you would actually find Q2 first. Q2 is actually the true median of the data set. This is actually the true median of the data set. So when I say you would find Q2 first, it's because Q2 would actually split the data into 2 equal halves. Okay, this is if you were doing this by hand. You don't have to do this by hand though. We can actually put this right in the calculator as well. And we're going to use the exact same keystrokes that we used previously. So I'm going to enter my values in. I'm going to press stat to do that. Edit is highlighted, so I'm going to press enter. And I'm going to use list one again. I'm going to go up to the name list one and I'm going to press clear, enter. Okay. And then I'm going to put these values in. So I've got 3, 8, 8, 6, 1, 9, 8, 7, 9, 6, 9, 5, 1, 6, 2, 9, 8, 7, 7, 9. Okay, so we put all the values in and we did not have to order them. The calculator is going to take care of everything for us. We just made sure we put them all in. And I do have 20 data values because it's waiting on number 21 if I had a 21. Okay, so I double check, make sure I don't miss any, type them in slowly, make sure you get them in right. Because if you miss one, your whole answer is going to be thrown off and everything's going to be wrong. Okay, so after we enter them in, you press stat and you're ready to calculate now. So go over to calc and we're going to use one variable stats again. Still using one variable stats because it's a single list of data values. So I'm going to select that and I put them in list one by default. So I would just keep pressing enter or go down, arrow down to calculate, press enter. Now, there's a little arrow here that indicates that there's more to see. If you arrow down, you will see the 5-number summary. Minimum value is 1. Q1 value is 5.5. The median, which is Q2, is 7. Q3 is 8.5. And then the max number is 9. Okay? So the one variable stats key will find the 5-number summary for us as well. And after that, you're asked to just create the box and whisker plot using the 5-number summary. You should be able to blow up the picture if you need to on the computer. My printer doesn't print in color very well. It's all black and white mainly because I'm out of colored ink. So it's kind of, not really hard to look at. It's supposed to be shaded, but it's fine if it's not shaded on the inside. The main thing is making sure that these values are correct. I'm going to sketch my own so that you can actually see how you show the box and whisker plot, what these pictures represent. So my scale, it goes from 1 to 9, so I'm pretty much going to count in units of, I guess I could count in units of ones. I should have enough room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I'll go a little past. So that's 1, and this is to 10. All right. Now my minimum and my maximum value, which is 9, 1 and 9, there I will have a dot. Okay. The box is created using Q1 and Q3. So Q1 is at 5.5. So I've got 1, 2, 3, 4, 5. This is 5, 6. So halfway between 5 and 6 is 5.5. And then Q3 is 8.5, which is between 8 and 9. And I make my box because it's called a box and whisker plot. So here's my box from Q1 to Q3. Okay. Q2 is on the inside. Q2 is at 7, which is right here. And then remember we put dots at the max and min. So then I create a whisker or segment, a line segment connecting the max and min values to the box. So there's my sketch, and we just need to pick out the correct one. It looks like it would need to be B. And actually, this is really easy to tell because B is the only one that has the minimum value at 1, at the correct value. This one has it at 2, that one has it at 2, and that one has it at 4. So picking out the correct graph is really easy. Okay? So that would have to be B. So again, I did not do this by hand, okay, but it is doable by hand if you want to do it by hand. To find the 5-number summary by hand, you would have to order all the data values. You would then find the Q2 value, which separates the data set into 2 equal halves. And then for each equal half, you would find Q1 for the lower half, which will be the median of the lower half. That's what Q1 basically is, the median of the lower half. And Q3 is technically the median of the upper half. Okay, but again, you can just use your calculator. Okay. All right, that is 2.1.